Yeah, so hopefully what I'm going to talk about dovetails nicely into the last presentation. So the title is Solving the Internet's Weak Link for Blockchain and IoT Applications. I'm just going to start out by doing a simple introduction of sort of defining what we're going to talk about. I'll try to do that quickly because I think most of you are well aware of the problem. I'll talk a little bit about what we think the solution might be and give you some examples of how we've implemented that. So when we talk about cybersecurity, we're talking about the occupant of cyberspace being digital data, and data meaning information, command and control, or identity, right? And the assumption we have behind that in cyberspace is that there are no boundaries, right? The data could reside anywhere. I want to be able to access it over innumerable devices and over innumerable networks, right? So the assumption here we're making is you want your data protected, and you only want yourself or somebody you authorize to access or control it, right? So by definition, cybersecurity is data protection and access control. Very simple. So when we think about data protection, again, the information, command and control, and identity, whether it's at rest or in transit, again, in this environment of no boundaries, how do we protect it, right? So the obvious answer is we put it in a digital lockbox, so we encrypt it. That's the right first step. And next, we need to have a ability to access that data, so we need to be able to decrypt it, or we need to have keys to that lockbox to unlock it, right? The natural set of questions that come is, how safe are my keys to unlock that box? And there are a lot of very fancy terms and applications around this, including things like homomorphic data access and so forth, that sort of confuse us. But it becomes really, really simple from our perspective. Where are the decryption keys stored? Can they be cloned without me knowing? And how does the system know it's me, right? So when we think about access control, or how do I use my keys, the methods that we use today that we've been talking about is, how do I authenticate myself to that box or to the network? I give information that I know, like my username and password or one-time password. I can identify myself with who I am, like my fingerprint or my Face ID, and I can add personally identifiable information, right? All of that, though, is centralized and clonable, right? So, for example, if Wilf wants to access his office and he walks up to the front door, he can identify himself in that locked front door by some sort of password. He can put his biometric. He can identify himself with his face or some information in his date of birth. Somebody on the inside has to know that that's the right answer. So that data has to be stored centrally and validated, right? In order for Wilf to be let in. The other option is that Wilf has a key to the door, right? So in this case, you may have something like a secure element, something that's decentralized and inherently unclonable, right? So then, even though we have a secure element, we have to ask, can my identity be cloned in bulk by others? And if it's a secure element, who manufactured that element and who's taking the liability for that particular set of keys that's being issued to me, right? So whether it's a traditional database we're trying to access, historically today, that information and command and control or identity has been centrally stored in a clonable environment. Blockchain gives us the ability to distribute that information and command and control. Immutable ledgers, it's a great first step. The weak link, though, is that the identity is still centralized. How we access it, still username and password by and large. Usernames and passwords, 8 to 10 character passwords can be cloned in about an hour to 2 hours with a very simple piece of equipment, right? So that's not a very secure way of approaching it. Whether it's a traditional database or whether it's a blockchain database, the idea would be to decentralize the identity and authentication, right? Therefore, using unclonable keys. So that's what we think the right solution is. So again, centralized databases make it easy for hackers to go and access your keys, whether they're doing it remotely, anonymously, and in bulk. And we've seen lots and lots of examples of that actually occurring. There are many examples in terms of Bitcoin. We saw Equifax hack. Now my personally identified information is gone. Our sort of solution is to decentralize that. So how do I enable a set of keys for individuals or machines that can be unclonable and decentralized? So now the hacker has to go and actually physically steal it from me. And in most cases, they have to know my PIN or other identifiable information to use it, right? Just like your credit card at the point of sale. So what we've done is we've sort of built that capability into a form factor that you're used to, credit card form factor. has a secure element built in. It's decentralized, it's unclonable, and in this case it's device agnostic because we've integrated not only an NFC radio, but we have a Bluetooth radio, Bluetooth LE integrated. So with the push of a button, I can authenticate myself over almost any device, so mobile phone, iPad, computer, even to a car, which I'll show you in a minute. And for machines, we took the standard IoT open source form factor using a micro SD card, and we integrated a secure element into it. So now I can place a secure element into any IoT device. It has the same unclonable identity. I can identify itself to the network uniquely with that same secure set of keys, right? So now the hacker has to go and hack individual devices or try to steal those identities. And if they do it, you're going to know it. You know if you lose your credit card. You'll know it if the machine's ID has been compromised. So I can go into the details of how we did this if you're interested. I'm going to skip over this because it might not be so interesting. But what you need to know is we've made this easy to use. And so what I thought I would do, and I can tell you how it works, and it works well, but I thought I'd just show you, and I don't know if I have sound here, but this is just showing you a really quick example of using our... sorry. Got it.
OS version 10.13.
Here we go.
The Chrome browser includes Web Bluetooth API. No software changes were required, and no software were installed. To digitally sign, Sideguard is turned on. PIN is entered in the browser to unlock the signing applet in the sidecard. Paired sidecard is selected via the Web Bluetooth API. The PIN along with necessary data is sent to Sideguard via encrypted Bluetooth. And Sidecard completes the signing process, as seen by the signed response in the browser.
So this is a really simple example using Chrome to sign a blockchain contract. And I do that without having to use my username and password or one-time password. I simply authenticate myself by turning the button on my sidecard. I access my secure element, I enter my PIN, and I've signed the contract. I'm done. And so the system knows it's me and nobody else but me, right? So here are some examples of what we did with an IoT device being a connected car with Jaguar Land Rover, identifying yourself personally to the car or to the backend network, and identifying the car uniquely to you and to the network. So we'll see if this plays.
iPhone and Jaguar Land Rover are working to bring secure, frictionless experiences to our drivers. Here are a few examples. With the Typhone sidecar, you can lock and unlock your car as an authenticated user. You can also provision that same encrypted functionality to your mobile device. This allows you to lock and unlock the vehicle with your phone and delivers more easy and secure actions. It enables you to remotely share secure entry to your vehicle with a trusted family member, friend, or coworker. Typhone allows for driver identification and personalization, adding security and comfort for your profile and any other authorized drivers. Typhone enables secure transactions right from your IVI. And it brings advanced control to authenticate account actions, like software over-the-air updates, an easy way to stay up to date. These innovations and others will be made possible through the ongoing collaboration between Typhone and Jaguar Land Rover.
So what we're trying to enable is actually a way that's not only secure but much more convenient. So instead of having to open an app, enter my username, password, switch apps to get a one-time password, re-authenticate myself that way, it's simply a push of a button. So I can lock and unlock my car, I can identify myself to my car. In the Jaguar case, we have an identity or profile stored in the cloud behind a hardware security module. That can be securely pushed to the car, so my data and information is there for me to access when I authenticate myself to the car, and can be pulled back. So I'm the one who controls my data, where my data goes. I opt in or opt out of those particular transactions, and allows me to have control over my information and anyone I want to share my information with. So those are just some examples of how we've implemented a secure element. There you go.
So, tell me how open the infrastructure is. Can other
Yeah.
In the concept of pushing the key out towards the edge of the code space, but then the question is, you know, in that awful situation where you set all this up and then Typhoon goes away,
Yeah.
right, is that information sort of locked up and lost? Are the keys proprietary, or can I take my keys to another platform of mine and re-engage?
So in a nutshell, it works just like the way that your credit card is issued. So the keys are escrowed, the cards are escrowed, they're never connected to a network, and they're issued to somebody. So somebody has to manage that, right? And so we provide the tools and the suite for you to implement that. It's all open APIs, so you can plug that into your system. And so, in other words, if you were to implement the solution, you don't have to rely on Typhoon to be managing that for you. It's something you manage yourself. But it does require some design into your system so that you have appropriate access control and appropriate management of the particular keys that you've issued or credential you've issued.
Going back to the discussion earlier
Yeah.
about the end game here is that we create a market for data.
Right.
I want to own my own data. I want to encrypt it my own way. I want to pay the price that I pay for high level security or whatever. I want to have it all. But then I want other people to be able to write applications that come and get that data.
Sure.
Given that I give them permission to use it. This is the platform. So I'm sort of trying to get the balance between what we have to enable the market to do in an open way versus how businesses like yours and Tosny build a business on that.
Right. Yeah, so I mean, the reality is ours is all open source and open standard. You just have to design it into your system or into your network. So in the case of Jaguar Land Rover, they want to have a specific relationship with you, so they're building it into their system, okay, so that they have a card that they issue you. Some of our customers are in the healthcare space. They want to put your data on blockchain, and they want to be able to escrow those cards. But in the case of a city, or you think of a company like Movil that provides a transportation card, or you have an identity card or something like that, now I can utilize that for whatever sets of services I want to opt in that particular environment, whether it be buying a bus pass or whether that be opting into parking or however you want to sort of create that infrastructure. I think the answer to your question, though, is there is some sort of continuity and synergy that needs to be designed in order to effectively use these tools across a number of different databases and systems. So that's just open standard sort of that we're going to have to define and allow us to provide those tools to people to access that.
Including, part of having people like DHS and NIST here
Yeah.
is this idea that let's figure out what we have to do to motivate them, how far they need to go, and then how much they can just step back and let commercial entities take it.
Exactly.
What do we have to do collectively to make this work?
Yeah, defining the architecture and how you plug into it, and then enabling folks to access those tools to be able to distribute the identification in this case. Yeah.
I was at the website the other day, and you have a dev kit available, right?
Yeah.
Can you talk a little bit about the dev kit and what you offer innovators to participate?
Yeah, so you have a range of things. We actually have a backend software platform that you can actually adopt and implement if you don't already have one. If not, you can adopt just our APIs to plug in to our system, and then we sell the hardware components sort of off the shelf, or we can send you to somebody who can provide them directly to you if you don't want to buy them directly from us, so a manufacturer. So the long and the short of it is it's a fairly straightforward again, open source, open standard set of tools that you can design into your system, your database. And then you can issue the credential if you want to be the one who escrows them, or you can use an outside source. We'll actually do some of that for you if you'd like. Right.
So around that development system, is there a store of applications, or do you guys look for licensing agreements?
We have developed specific applications for customers. In our case, our main customer base is banking and credit unions. We built applications, as I mentioned, for blockchain signing. We're building additional applications around healthcare and logistics, so sort of supply chain management. We're building the applications around automotive and connected cars or connected transportation. The short answer is we can do that with you or for you, or you can do that yourself.
Well, let's say we wanted to put together a startup weekend hackathon or something like that.
Mm-hmm.
well, this is great, we want to focus on this particular problem, and that's endpoint identity. What would be the restrictions on those innovators? They have to sign a licensing agreement, give away half of the profits?
No. So how do you buy it from it? How do you use it?
Yeah.
So to answer your two-part question, one is we want to give you the tools and let you go run with it. We don't want to be the bottleneck. So you can go implement these things. The innovation for us was making it convenient and easy to access a secure element, whether that be for an IoT device or for personal identity. So we want to get that to you. There is a license, so we do want to get paid for what we have. And it's a very simple, most models that we've followed are usually, depending on what level of software and what level of sort of app development you're asking of us, it's usually a very simple monthly fee. Think of like an RSA sort of a contract where you pay $1 a user a month kind of a thing, and you have access to these tools. Yeah.
Fair enough,
Yeah. Is that helpful?
It is. I'm just thinking of the key by the car. So the car is potentially generating information. So,
Right.
and I may want to get at that information.
Mm-hmm.
And the car has a key, and I assume that I have access to that key as the car's owner.
Yep.
And I can delegate access to that to third parties. Is that?
That's exactly right. So I'll give you a couple of examples. Jaguar Land Rover is one, Porsche is the other one. So your cars are gathering tons and tons of information. Porsche actually wants to control that and not let Apple or Google. They're actually loading it onto a blockchain and locking it with a set of keys and saying you have control, that's your data. You can opt in to sharing that or not. So even though that's our car that you bought, that's your data. It's your location, it's, et cetera. And so therefore you have the opportunity to opt into a set of services that they may offer you to share your data, other apps and things they may want to offer you to consume, even opening that up to other third parties like Apple and Google to access that data. But you're the point of control. JLR is doing the same thing, right? Because again, they have tremendous number of sensors. It's your heart rate, are you sleepy or tired, your location, how fast you're driving, all those sorts of data points are aggregated now in the car. As we move to autonomous driving, right, your car becomes your mobile office or your mobile living room. And so the notion of consuming things, content there, becomes even more important. They want to be able to push offers, services, other things to you in that environment because you have more time to be a consumer there in that space. So the competition over who owns that control point, who can sort of interface with you, is sort of the digital space the automotive guys are playing in relative to Apple's and Google's, becoming digital companies, if you will. Did that answer the question?
It does.
Okay.
It does. It opens another really big one.
Yeah.
But the big one it obviously opens is the one you say, which is, do I want objects in my environment that I purchased to be collecting data I don't have access to? Right?
Yeah.
And so let's say it's the car, right? If I buy a Porsche, does that mean that Porsche knows my driving habits and I don't have the ability to access it? Right? And it's how you manage those keys, right? If Porsche
That's right.
delivers it with the key on board that they own, right, then there's an issue.
Yeah.
This is going to bring up a lot of issues associated with data ownership. I mean, it's the downside of what you said earlier, right? That this mechanism allows me to own my own data, but it also allows others to own data they collect about me. Is there some regulation that says they have to tell me they're doing it?
So this is a great point. So with European manufacturers, GDPR says yes. They have to, if they're collecting their data about you, they have to let you know, and you have to opt in.
When you buy the Porsche, you have to sign something that says, I understand that all this data is being collected on me every time I drive my car.
Or, depending on the layers of data, you push your button, because now you have a secure element that locks your data, and they say, may we use this data? And you say yes or no.
Yes. Obviously, that's the right way to do it.
Yeah.
Right?
Do you know how they're kind of navigating what?
Requires the industry to stay, and that's what we're talking about.
Yeah.
Yeah.
And I think that'll come after $3 or $4 billion for the clients.
Right,
It might come after you can't sell a Porsche to somebody because everybody goes, yeah, I'm not going to be tracked, right?
Yeah.
There is an issue there but people have to be aware of it. That's why the GDPR is so important, right? I'm perfectly happy to give someone access to the data. If if I choose to do it. What I don't want is I don't want to buy the Porsche and 5 years later find that Porsche's collected all this data on me.
It's a secret surveillance stuff.
It's a secret surveillance.
The other thing I think,
Except that then I drive into my garage, it picks it up on Wi-Fi, and now they've got it all.
you may know more about this than I do, because I'm currently studying GDPR. But I think they also require that if they change the rules, that you have to have informed consent. In other words, if they decide to use your data for a different application,
Yes.
or sell it.
Very specifically, you have to identify the
You have to
application.
tell people how to. The part that we've been struggling with in that whole framework on the superpost for data is what happens with derivative data. So, in other words, you can say, I just want to look at your personal data once. Okay, it's yours, and I'm done with it. Now, what I've done is I've derived a whole set of inferences, a social graph, a psychic graph, use cases and so forth from your data. That's a derivative.
Mm-hmm.
So in some cases, like if you look at models that are out there in other places, Free Software Foundation says, by signing this, you're using this software, this free software, and you inherit the rights of free software, and it shall remain free. So they say that the next person who modifies the software has to make that contribution back to the base in order to continue to use it. Now there was a lot of pushback there because of the monetization of software, commercialization of software, and so forth. But the concept in data, we're looking for models and the concept of data licensing that allow us to somehow manage this derivative thing. Machine learning takes tons of data. It may only have to look once, and it has enough information there to say, I don't need your data anymore. I know exactly who you are for my purposes, and here's your data back. I don't need anything data over time. Now clearly, data over time is more valuable than just a snapshot of data. But the derivative data and its licensing is a real conundrum. We haven't found a decent way of approaching that, and I think that's one we want to put in front of all the smart cities people, stakeholders, and so forth to say, is it an issue? Is it something we should be concerned about? Is it something that we just say is part of the transparency program? We know social media, they have tons of derivative data. That's how they drive ad sales, because they say you fit in these various categories of behavior, therefore you're one of the people that this ad should be displayed to. Now that's not particularly nefarious when it comes to selling you something. It's only somewhat nefarious when it comes to influencing what action you're going to take the next day. So first example there is if they send a button to you that says all of your friends voted, because they checked off a box and said, I voted. Well, what turns out is you vote. Where the majority of people go like, well, my friends did that, I'm going to go vote too. Thanks for reminding me. And if you do vote, the likelihood of you voting Democratic is higher. And so the election is skewed towards Democrats if more people turn out. That's just statistics. So
It's skewed to whatever demographic they serve that button to.
no, it's just true enough, but in general, the more people that turn out, the more the
Unless you bias the people who tell you.
unless you're specifically
So
targeting those
what you're
people.
saying is relevant. So the question really is about this. Is there any mechanism that you've thought about derived data being in any way attached to the original data through some kind of keying mechanism that would allow you to know that your derived data is being used? Right? So think GDPR. I give permission for my data to be used.
Yep.
But if that data is then used to derive something about me, and I now no longer have that link, is that causing a problem that we can't fix?
The way that we've implemented it at Jaguar Land Rover and the proof of concept is we can derive derivative keys to share our information or access to our car, that sort of thing. And those can have constraints put on them. They can be temporary, they can be time-bound, they can be set up however you want them to be set up, right? And then they expire, right? And the question is, if somebody accesses your data, right, and they pull it into a new database, once they've done that, how do you manage that? Okay, that's a bigger problem, right?
Because in fact, if I'm a scientist or a medical researcher or whatever, and I have all of this wonderful data that's been depersonalized, and I'm looking at that, I can't claim that this is valid data unless I can put this out to the original person.
Right.
If I don't have a relationship to the original data, I can't say that
Well, if you can close the loop, though. Yeah, so I have to re-authenticate.
There are, so there are anonymous group attestations that would meet that purpose.
Anonymous,
So,
you mean like zero knowledge groups?
well, they use zero knowledge groups, but no, there are attestations where you can go back and trace it without revealing the end.
Right, yeah. Yeah, so, but we don't, this is good that they're
Yeah, I
there.
know, that's
But
right,
should
nobody's using
should it be a part of what we, you know, we're trying to create a blueprint, which is just
Right.
best practices
Mhm.
in the data supercluster that says, if you're going to deploy these things, here's some considerations, here's some boilerplate potentially for, we're talking with a number of legal counsels. So here's some boilerplate that you might want to use to assure, to raise the level of trust that citizens have in this process, to get the participation higher, and to conform with good practices, you know, and not just the legal aspect, which is good practice. So I think I like what you say, in that there are attestation, things, processes that will attest to the validity of that data and its original source. Zero knowledge group can be part of that, and that's how they obscure a lot of these Bitcoin-like cryptocurrencies, and they can't see what's in them. Anyway, the long and the short of it is, we're working hard. We encourage anyone that wants to join the Slack team and start dropping in notes, especially on our aspect of the boilerplate, not boilerplate, the blueprint and best practices for security for data platforms. Because we certainly need that. There's lots of ideas going along, but it isn't a four-person. We've got 3 co-chairs, and we've got about 80 members. And we have this is one of the hottest topics. So unless, you know, I'd be happy to turn the effort over to any other supercluster.
No, we need to collaborate on this. I mean, obviously, this is